For Algebra 2, Chapter 7.6 starts off with function operations. For the addition operation, f plus g of x can be rewritten as f of x plus g of x. Multiplication, f times g of x can be rewritten as f of x times g of x. Subtraction, f minus g of x can be rewritten as f of x minus g of x. For division, f divided by g of x can be rewritten as f of x divided by g of x, as long as g of x is not equal to 0. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. The domain of a quotient function, however, does not contain any x value for which g of x would equal 0. That would give you 0 in the denominator. That's why they cannot work. So, for example, if we let f of x equal to 3x plus 8 and g of x equal a 2x minus 12, if we would want to find the operation f plus g of x, I would first personally rewrite it as f of x plus g of x. I would then substitute in our operation. So for the f of x, I plug in the 3x plus 8. For the g of x, I plug in the 2x minus 12. We then just go ahead and do basic Algebra 1 rules. Since it's a plus, we can drop off the parentheses if we would like. A 3x plus a 2x, and then an 8 minus 12. That ends up giving you a 5x minus 4. Our domain for this would be all real numbers. If we would go ahead and do f minus g of x, again, I would rewrite it. F of x minus g of x. Plug in our functions. Gives us a 3x plus 8 minus the quantity 2x minus 12. I would distribute that negative to the 2x and the negative 12. So that gives us a 3x minus 2x and then an 8 plus 12. Ends up giving us an x plus 20. Again, our domain is all real numbers. Now, let's change up our functions. Let's let f of x be a x squared minus 1, g of x be an x plus 1. I want to find f times g, and I also want to find f divided by g. So first, the f times g there should probably be in parentheses. That's my fault. So f times g of x, I'm going to rewrite it as f of x times g of x. Substitute in. That gives me my function x squared minus 1 times my function x plus 1. I will have to use the FOIL rules. So x squared times an x. That ends up giving you an x to the third. X squared times 1 would be plus x squared. We then have the negative 1 times the x, which is a negative x. And then a negative 1 times a 1 gives us negative 1. Our domain for this would be all real numbers. Now, as for our f divided by g of x, I would rewrite that again as a f of x divided by g of x. So plug everything in. What I would do with the x squared minus 1 is I would split that apart to where it becomes an x plus 1 times an x minus 1. The reason why I'm going to do that is because now I can cancel out my x plus 1s. That gives me an x minus 1 as my answer. Now, for the domain here, we have to remember that our g of x cannot equal 0. So what I'm going to say is our domain is all real numbers excluding a negative 1. The reason why we have to exclude negative 1 is because if we have a negative 1 as our x, negative 1 plus 1 gives us 0, and 0 cannot be in the denominator. So next we need to talk about composite function, or composite functions. It's a combination of two functions. It is written as g of f. Now, that is an open circle. Do not get that confused with multiplication. So it's written as g of f, and is defined as g of f of x equals g of f of x. The domain of g of f consists of the values a in the domain of f, for which f of a is the domain of g. Whenever you are given this, I would always rewrite it as you see there in the color. The reason why I have those different colored is because the f of x, I would do it first. I would evaluate f of x, so that's the inner function. Your result will then be the input for your second function, which will be g of f of x. So for example, if we let f of x equal an x minus 2 and g of x equal an x squared, if I ask you to find g of f of negative 5, we have to do the inner function first, so that would be the function of f. So I'm going to write f of negative 5 equals, what I'm going to do is I'm going to substitute in that negative 5 everywhere I see an x for the function f. So if I substitute in the negative 5 for the x, that gives me a negative 5 minus 2, which we all should know that negative 5 minus 2 is a negative 7. So that was my result of the first function. Since that's my result, I now use it as my input for the g of x, which g of x was x squared. So now I'm going to say g of f of negative 5 equals, since my end result of f of negative 5 was a negative 7, I substitute that in for my x for the function g. So a negative 7 squared ends up being a positive 49. Now, it does matter the order that you do this. So if we switched it up and did f of g of negative 5, I have to do my g of negative 5 function first. So when I substitute in that negative 5, it gives me a negative 5 and then squared. That ends up giving me 25. Since that's my end result for my first function, I use it as my input. So I'm going to say f of g of negative 5 equals, I substitute in 25 where I see an x in the in the f function. So 25 minus 2, which ends up giving us a 23. If you have any questions, please come see one of us.